Hello there, Mr. MathWell here. This video is about the product rule for finding derivatives, and you have a product of two things, they're multiplied together. This is the rule that we must use for the product. Now, it's different than the sum difference rule. Remember the sum difference rule, which we just did. If we have f plus g, and we're trying to take the derivative of that, the sum rule says that we could just add together the derivatives, and that's okay. But let's check to see if the derivatives of a product, that is, two things that are multiplied together, is the same as the product of the derivatives. So can we do this? Is f times g, is that derivative the same as f prime times g prime? Okay, that's the question. And I've got a couple examples set up. So you can copy these down, or you can just watch here as I do this. But I'm going to split 12x squared into, let's say, 6x times 2x, okay? So again, I want to express this as a product because we're testing the product rule. What's the product rule? So it would be nice if, let's see, the derivative of 12x squared was the same as the derivative of, one of the factors right here times the derivative of the other. That would be nice. Let's check it out to see if it's true. Power rule says this is 24x, okay? Now let's just see if the derivative of 6x times 2x comes about by just taking the derivative of each factor and multiplying them. So the derivative of 6x is 6. Derivative of 2x is 2. So 24x does definitely not equal 12. So that doesn't work. Over here, we could try the same thing, and I'll do that real quick. So the derivative here is 2x plus 2, right, plus 0. So that's the derivative of this trinomial. And the derivative of the individual factors, if we just multiply those together, this would be 1 times 1. So these are definitely not the same. So we need to have a product rule. It's a rule that's just a tiny little bit different. This one's a bit of a stretch. You'll have to do some memorizing here, but this is definitely not true up here. Okay, now I'll show you the product rule down here is what it is, and we'll just test it out with a few examples. So if you have, let's say f and g are factors, okay, of something, the product fg, you can't just do f prime times g prime and be done. Instead, what you do is this. You take the derivative of the first factor and you multiply it by the second. So it's important to note that you do take the derivative of one, but you don't take the derivative of the second one right away. Then you add to that, and you flip the first factor on its own times the derivative of the second. So it's f prime g plus fg prime, or derivative of the first times the second plus the first times the derivative of the second. So we have to split this up a little bit. So let's try it up here. All right, so we're not going to do the derivative of just 6x and multiply by the derivative of 2x, but we're going to do, find the derivative here. We're going to use the product rule. So the derivative of the first, that's 6x, is 6, times the second. We leave that alone. Now we add the first factor on its own, leave that one alone now, times the derivative of the second, 2. So this is kind of what we have here. We have this split up this way. And see what happens? We have 12x plus 12x is 24x. And that seems to work out. Now let's try this one. What did we say this one was? 2x plus 2. Let's try the product rule on these two factors. Remember, these two multiplied together give you this. So we can work on the factors. So the derivative of the first is 1 times the second plus the first, that's x plus 1, times the derivative of the second. Okay, so if we go ahead and simplify this, this is simply x plus 1 plus x plus 1, or 2x's plus 2. The same. Okay, so the product rule seems to work for these two examples, and this is the reality for anything that you can split up. And down here, I split up 12x squared differently. See, over here I did 6x times 2x. Oh, no, I did the same here, I guess. But we could change this. Let me change this for you. So let's say, well, I'll split up anyway. Let's go 12x times 1 times 1x. Okay, 12x times x. So the product rule, and we know it should be 24x, right? That's the derivative. So the product rule says the derivative of the first times the second plus the first times the derivative of the second. There you go. 12x plus 12x is 24x. And one more time over here, let's do this. The derivative of the first is 6x times the second plus the first, 3x squared, times the derivative of the second. Now the derivative of a constant is 0. So this is 24x plus 0. So the product rule is beautiful. It works. Yeah, I showed you this one earlier. Okay. Now, and this example is a bit busy here, but I'll show it anyways. In this example, what I did was I took two binomial factors, I multiplied them, I expanded them first, simplified, to get this polynomial right here, see? Then I did the sum, difference, and the power rule to get the derivative. So that's one way to do it, but you know, you're not going to want to expand things very often, so you're going to want to try and use the product rule, and that is over here, the derivative of the first times the second plus the first times the derivative of the second. When you simplify all that, you get the exact same as you would have gotten over here just using the power and sum rule. I will do one more example with you here real quick, and that's if you have something crazy like this. You have x squared and you have over root x. Now you could simplify this, right? You could simplify this and use probably just a power rule. How would you simplify this? Well, you could write this as x squared times x to the negative 1/2. You see that? Because this is a positive 1/2 as a power down here. You bring it up, you flip the sign. And then we could simplify this further by adding the exponents when the bases are the same. So 2 plus a negative 1/2 would be x to the 3/2. Okay, and then you could do power rule, 3/2, x minus 1, that's 1/2. So that's 3 root x over 2, looks like. Okay, well, let's go back over here and let's do product rule. I still have this as a quotient, so the quotient rule is next, by the way. But product, eesh, what do you do? Well, let's write it it's sort of like I did over here. You see that? Derivative of the first times the second, okay, plus the first times the derivative of the second, negative. That's negative 1/2. And this becomes, what's this minus 1 is negative 3/2. Okay. All right, there we go. Now we got that better. So what do we got here? This is 1 minus 1/2. That's 2x to the 1/2, right? Plus, oh, that'd be a minus because there's a big fat negative right there. So let's make that minus. It's going to be 1/2, and then what's this? 2 minus 1/2. What's 2 minus 1/2? That's going to be x to the positive 1/2. Okay, so now 2 minus 1/2 is actually 1/2, which as a fraction, 4/2 minus 1/2 is 3/2. So that's 3/2, and they're the like terms, so it's 3/2 x to the 1/2, which of course can be written as 3 root x over 2. Now we have the same thing. So product rule. Yeah, it works. Even on the tricky ones, okay? You just got to copy your signs down right. Okay. All right, so that is the product rule, and it's a little more complicated than sum difference rule, whatever, deal with it, it's life. Yeah, hope that helps. Derivative of the first times the second, plus the first times the derivative of the second, right here. Study that, memorize it, get to know it, love it, use it every day. All right, see you later.